Okay, so this is going to be just a quick overview of the first few problems for the microscope measurement practice, simply because the other problems were just variations of these. So in the first problem, you are looking at a cell under a microscope, and since you do not have any micrometers or measurements or anything going there, you're just going to have to estimate the size. So the best way to do this is kind of draw an imaginary line or a regular line straight down there, and then estimate approximately how much of the length of that is being taken up by the organism. Most people would say it's about a third. So if you just take 30.3, change it into decimal, and the problem tells you that it's at 40 times, so it's 4,500 micrometers. And if you just take that and multiply it by 4,500, you'll get an estimated size. And that estimated size is going to be about 1,500. Now, if you did this at 0.33 for exactly a third, then that's going to be 1485. So you can get a range of answers here and be okay. So the next question, question 2, is saying this is the actual drawing of the organism under the microscope. And so now that you know the actual size, you want to add a scale bar and then give the magnification of the drawing. So the first thing to do to the scale bar is you want the drawing side here. This is the formula that you have to be able to remember. And then you want the scale bar that you draw to be under here. Then you will simply do a ratio to the actual size here. And then you want to know what size is the scale bar underneath it. Okay, so the first step is you need to actually draw and determine with a straight line, this is not exactly straight, how long the organism actually is. And if you measure that with a ruler, you're going to get about 6 centimeters. And so 6 centimeters will convert into 60 millimeters, which will then convert into 60,000 micrometers. And I would suggest that you go ahead and change everything into micrometers as soon as you do it. That way you don't have to worry about units at the end, and your units do need to be matching on either side. Then you would draw a scale bar in. So you would just draw the bars like this. And then the next step is you need to measure the scale bar with your ruler. So the scale bar that I used in the example online, I made my scale bar 2 centimeters. And so 2 centimeters is going to go into 20 millimeters, and then that will convert into 20,000 micrometers. So that's the drawn side of my scale bar ratio. So you're going to look at this like this. You're going to say this is the paper side, things that you draw or measure on the paper, and this side is going to be your micro side. In other words, these are things that are represented or seen under the microscope. So now the actual size, I'm going to go ahead and use 1485 because that's from the example online with the key, and then I am over x. So all you're going to do at this point is solve for x, and x is going to be equal to 495 micrometers. Just to make sure you are plugging the numbers into your calculator correctly. That means that this scale bar is 495 micrometers in length as a scale. So 2 centimeters of a scale bar represents 495 micrometers under a microscope. Now I need to determine the magnification that this was actually drawn at. So this is the magnification equals the drawn size over the actual size. Well, you now have both of those measurements. So the drawn size is 60,000 micrometers, and again they need to be in the same units, and the actual size was 1485 micrometers. So when you do the math there, the magnification of the drawing is going to be oh, did I not put the answer on that? Oh, no, I'm sorry. You didn't have to do the magnification of the drawing. But if you had to do the magnification of the drawing, you would do it that way and just put this and put an X next to it to indicate this is how many times the problem is. I was skipping ahead to the next problem. Okay, so problem 3, it tells you that it's drawn 2,000 times larger than life size, and it wants you to add a scale bar and determine the actual size of the cell, not the drawn size of the cell. So this is going to be the magnification formula. So the magnification equals the size of the drawing divided by the actual size of the cell. And so this is one that you will need to know. So you have the magnification as 2,000 times. Now to get the drawn size, you literally will just draw a line across there or measure it with your ruler. And the measure size of this, I put it as 5.3 centimeters estimated. And then that's going to be 53 millimeters. And again, you want to change everything to micrometers. So this is going to be 53,000 micrometers. and then you're going to divide that by the actual size. So this is what you're solving for. So this is your x in this example. So then if you do that, you solve for x, and x, the actual size of this, is going to be 26.5 micrometers. And then you'll follow the same procedure to do a scale bar. You'll draw a scale bar here. You'll measure it out. I think I put my scale bar again as 2 centimeters, which would be 20 millimeters. And that would be 20,000 micrometers. So now I have my drawn size as 53,000. I have my micrometers for my scale bar as 20,000 micrometers. My is going to equal 26.5 is my actual size of my cell divided by x. And so once again, when I solve for x, x comes out to about 10 micrometers. So that means that this scale bar represents 10 micrometers. So that's problem 3. So now for problem 4, I mix these up, and if you did part B first, you can get to part A, so I apologize for that. So again, the max width of the cell, measure a line across the cell, and so the max width that I did here is I measured it at 75 millimeters. Okay. Now, here is the problem with this one. You are given a scale bar already down here at the bottom. And if you measure that scale bar, the scale bar is approximately 17 millimeters. And in this particular case, it doesn't matter that you keep the units as millimeters, and actually it's going to be easier. So when you divide this, this is basically telling you how many scale bars across is this particular cell. So when I divide that, I'm going to get 4.41, and the reason I say the units aren't going to matter is the units will cancel themselves out. Then this scale bar is equivalent to 2 micrometers. So then you need to multiply by 2 micrometers, and now you can see where your units come back. So the width of this cell is actually 8.82 micrometers, because you can't measure this in micrometers, and even if you did, it's still going to cancel out. So it's better that you measure in millimeters when you're measuring a scale bar, and then just cancel your units. And if you need to, look at your scale bar measurement and multiply by that measurement. So that is the width of the cell, which now you can determine the magnification, which is also given to you right here. So you should be kind of close to that. Is going to be, again, the drawn size that you measured divided by the actual size. So now the drawn size is going to be, change this into micrometers, 75,000 micrometers, and then I'm going to divide it by 8.82 micrometers. And again, your micrometers, your units here are going to cancel out. And then the magnification, if you calculate it that way, is going to be about 8,503. And you'll notice that this number is off a little bit, but it's pretty close to this 9,041 number here. So when you're working these problems, there is going to be a little bit of a range given in your answers. So as long as you're within that range, you should be fine.